This problem tells me that when I react solid sulfur with gaseous O2, it forms sulfur trioxide SO3. I haven't written solid gas or gas just because I'm trying to be lazy, I suppose, and save myself room. Nevertheless, it goes on to say that in this particular reaction, we produce 7.9 grams of sulfur trioxide when we react 5 grams or 5.0 grams of O2 with 6.0 grams of sulfur. It then goes on to ask what the percent yield of SO3 is in this reaction. In order to do this, the first step that we always have to do is to balance this chemical equation. In this particular case, it tells us specifically that it is not balanced. So if I look at this and try to add some coefficients, I think that if I put a 2 over here, yeah, then I have 6 oxygens on the right. If I put a 3 right here, now I've got 6 oxygens on the left. And then if I put a 2 right there, that should balance the overall equation. Now I've got a balanced equation. The next step that we always do is convert to moles. Convert to moles, convert to moles, convert to moles. Always. There's no way, and I see students do this all the time, you can't convert from grams of sulfur to grams of SO3 directly. You always have to go through moles. Grams and grams never touch, but moles can touch each other. So let's go ahead and do that. I'm going to, first of all, do this starting with sulfur. I'm going to write down 6 grams of sulfur. How many moles is that? Well, 1 mole of sulfur, if I look at the periodic table, weighs 32 grams. So the grams cancel each other, and I end up getting a certain number of moles of sulfur. I've done that already, and that amount turns out to be 0.1875. Now, I'm not writing out the proper number of significant figures, and right now, at this point, I don't care. 5 grams of O2. Now, keep in mind that 1 molecule of O2 actually has 2 different oxygen atoms, each of which weighs 16, so it also weighs 32 grams. So the total number of moles of O2 that we end up with is 0.15625 moles of O2. And then I've got 7.9 grams of SO3. 1 mole of SO3 weighs 80 grams. My grams cancel each other out, and I end up with 0.098, that's a 9, 75 moles of SO3. So I've now converted everything to moles. So what I'm going to do is I'm going to basically erase these amounts. I'm going to erase these amounts, the grams, and I'm going to rewrite moles. So I've got 0.1875 moles of this thingy, 0.15625 moles of that thingy, and then 0.09875 moles of SO3. Now, in order to give myself room on the board, I'm going to go ahead and erase this, so feel free to pause and take note before it's gone. The next step that I do is I use these stoichiometric ratios to determine what the limiting reactant is. How in the world do we do that? Well, the way I usually go about doing it is I pick one of these 2 reactants, and it doesn't matter which one you pick. And I ask myself, given the number of moles of that reactant that I have, do I have enough of the other reactant in order to react with the number of moles of the previous reactant that I have sitting there? Okay, that's kind of a stupid way of wording that. Let's go ahead and pick one of these reactants. And I honestly don't care which one I pick. It doesn't matter. I'll go ahead and pick sulfur because I read left to right. So we'll go ahead and pick sulfur. So here's what we're going to do. We have 0.1875 moles of sulfur. So I'm going to write down this question. If I have 0.1875 moles of sulfur, and I do in this case, I had 6 grams of sulfur, which comes to 0.1875 moles of sulfur, how many moles of O2 do I need? So that's the question. This is the word need, sorry. So I'm going to go ahead and write that out. 0.1875 moles of sulfur. How in the world do I determine how many moles of O2 I need? I use the coefficients of the balanced stoichiometric equation. So I'm going to write down moles of sulfur in the denominator so that it cancels out the moles of sulfur in the numerator. And I'll write down moles of O2 in the numerator. Then the numbers that I put in here, well, this is added in a ratio of 2 moles of sulfur for every 3 moles of O2. Got it? Okay, so the moles of sulfur cancel each other out, and I end up determining that if I have 0.1875 moles of sulfur, I end up needing 0.2813 moles of O2. So this is how many moles of O2 you would need in order to react with that many moles of sulfur. Hopefully you're okay with that. So if I have that many moles of sulfur, how many moles of O2 do I need? That's how many moles of O2 do I need. So the next question is this. Do I have at least 0.2813 moles of O2? That is the very next question I ask. In this equation, do I have at least 0.2813 moles of O2? If the answer is yes, then that means that I've got excess O2 and sulfur will run out first. If the answer is no, then that means I don't have enough O2. O2 will run out first. I've only got 0.15625 moles. That is a number that is smaller than 0.283. So the answer is no. So O2 runs out first. And what I mean when I say runs out first, that means that O2 is the limiting reactant. So I'll go ahead and write this down, limiting reactant. That is the most important thing to figure out through this whole process, because everything that you calculate from this point forward is all done from the limiting reactant. I know that sulfur is in excess. There's way more sulfur than I need, so the amount of SO3 that I get out the other end is going to be determined completely by the thing that's present in the smaller ratio, which is going to be this. Notice that the limiting reactant has nothing to do directly with the coefficients in front of these. It's all related to the amount and which one of these runs out first. Now, in order to give ourselves some room, I'm going to go ahead and erase this. So go ahead and pause, take note of what I've written here if you need to, and then you can go ahead and play afterwards and I'll have this erased. What I'm going to do, though, is I do want to point out that this is the limiting reactant so that we don't forget. It's the thing that runs out first. So all of our calculations will be done from our O2. So now that I've figured that out, I'm going to have to take this 0.15625 moles of O2 and determine how many moles of SO3 I should get out if I put in this many moles of O2. I've got excess sulfur. I don't care about the sulfur anymore. So let's go ahead and write this down. I've got moles of O2 in the denominator, and I've got moles of SO3 in the numerator. What numbers do I throw in there? Well, it's a ratio of 3 moles of O2 to every 2 moles of SO3. Yeah? So the moles of O2 cancel each other out, and that ends up giving me a certain number of moles of SO3. And that number comes out to be 0.1041. So in this reaction, I've got excess sulfur. I threw in 0.15625 moles of O2. If everything went perfectly, I should get out 0.1041 moles of SO3 out the other end. This is what I should have gotten if everything went perfectly. This is my theoretical yield. The amount, theoretically, that I should get if everything goes perfect. Now, it tells me that in reality I actually got 7 grams of SO3, which translates to that many moles. So this is the actual amount or actual yield of SO3 that we actually got. If everything went perfect, we should have got this much. We didn't know, we got this much. So how in the world do I get my percent yield? Well, percent yield is equal to actual divided by theoretical. It's just like a grade on an exam. If my theoretical grade on an exam is 100%, but if I got a 95, I just take 1 divided by the other, times it by 100 to get the percent. So actual here is up here. That's how much I actually got. It's 0.09875. Theoretical is 0.1041. I times that by 100, and that should tell me my percent yield. And that percent yield I did earlier comes out to be 94.5. Now if I round for the proper number of significant figures, that translates to 95%, which is one of the options in this multiple choice question. That is how you do a percent yield question.